Met watter grafieke is ons besig? Ek wil amper sê soos met watter van ons gewone grafieke is ons besig wanneer ons kyk na laagfunksies? Are we looking at parabolas? Are we looking at hyperboles? Are we looking at exponential graphs? No. Exponential graphs. Oh, yeah, we are working with exponential graphs. So what you guys need to understand is log functions or anything with a log in relates strongly to anything you know about exponents. Okay? So as ek vir julle gaan neerskryf die log wette, we have a few laws when we are working with log functions. And the first one looks like this. If you have log, that mustn't be a capital. That. So log van x, and then in the log function you have a times b. You can extend that to log x a plus log x b. No. Okay, so remember that's what we're working with, né? As ons gaan kyk na hierdie, onthou julle in graad 8 het julle gedoen as jy twee grondtalle met of twee goeters mekaar vermenigvuldig en hulle grondtalle is dieselfde, dan tel jy die eksponente bymekaar. Do you guys remember that? Do you see that when I go and write this in a log function? Stem julle saam, daai is die grondtal. It's the number down there. Do you see that? sien julle dit? Okay. So when we have that at the bottom, then we're basically saying, when I have two of those that are the same, and you are multiplying them with one another, then you add the terms together. So hierdie is basies net 'n baie fancy manier om daai eksponentwette wat julle in graad 8 al gedoen het, net hier te gaan omskryf. Or you can just study it. So an example of this will be, let's say log of 4 is equal to 8. Then you can write it as log 4 2 plus log 4 because 2 times 4 is 8. So you can break it up there. En ons sal kom by hoekom dit nodig is, but this can simplify to 1. Okay, yes, Lauren.
So the A is basically the base.
In this case. This is what we did on Friday. I just want you guys to see the link between the exponential laws that you did and these log laws. If we are multiplying, then we are adding.
Is there a specific way that you divide it? Or can you, like, for example, that could be divided? I don't know.
It can be divided in another way, but I would have gone with 4 because log 4 is equal to 1. Always when this and this is the same thing, it's equal to 1. You guys won't get tested on the log laws, but you do need to know these. Like, they're not going to give you a very difficult example and you need to simplify it. But if you can't do these, then you're going to struggle with some of the other ones that we're going to do. We're only going to do applications. Then the next one looks like this. What did we do with our exponential laws when we divided? What did you do to the exponents? Jy het hulle afgetrek by mekaar. So just apply that here. It's log xa minus log xb. Because we are busy with exponents the whole time. En onthou daar's ander reëls wat werk vir eksponente as wat werk vir gewone getalle. Okay, this one is very important. You're going to use this one often, and not just here, you're going to use it with calculus as well, and with finances. And with finances. That's actually where we use it most often. Okay, so sien julle hierdie is 'n eksponent binne in hom, and then you just go and write it in front. So you're taking it out of the exponent. Dan kan jy actually met hom werk. And then the last one looks like this. I'm going to write out the example of this one as well. Okay, so let's say we have log 4/8. Then you can write that as log of 8 over log of 4. Okay, then I'm going to change 8 and 4 into the exponential forms. Onthou hier staan nou eintlik 'n 10, but I'm not writing the 10. Okay, nou gaan kyk ons na daai wet. If it's log with a base and an exponent, then you can take out the exponent and write it in front. So I can write that as 3 log 2 over 2 log 2. Dis 'n application van daai ene, which is 3 over 2. Like that. Okay. En julle gaan meer gemaklik met hierdie woord hoe meer ons hulle gebruik in somme. We're only ever going to use them to simplify something. Not ever going to give it to you and say, calculate the value of x, and then you have a long one, but you have to be able to apply these. Yes, Jelly. Dit moet net so lank daai dieselfde ding is. Dit kan enige iets wees. So in hierdie geval het ons dit nou log 10 gemaak, maar ons kon dit log 5 gemaak het ook. Maar log 10 is die ene wat net so op jou sakrekenaar is ook, so hy is die maklikste een om mee te werk. Solank dit net dieselfde getal is. Okay. Good, but I want to get to drawing the graphs today, so let's start with those. So they tell you f of x is equal to 2 to the power of x. Okay, we're first only going to draw that graph. I just want you guys to check, do you agree that the point 0 and 1, and let's say -1.5 and 1 and 2 will be on that graph. Okay, ek gaan stel gou x waarde 0 in, dan is y waarde gelyk aan 1, want enigiets tot die mag 0 is 1. If I substitute x value -1, then 2 to the power of -1 is a half, and if I substitute x value 1, then 2 to the power of 1 is 2. Okay, stem julle saam, daai is 3 punte wat op hierdie eksponensiële grafiek gaan lê. And the shape, because that is between 0 and 1, is ascending. En ek gaan net gou daai punte op hom aandui. What is the equation of the asymptote of that one? Close. Y is equal to 0. Nee? Stem julle saam? The asymptote of this one will be at y equal to 0. Met ander woorde, die x-as. Nee? Let's talk about the definition. Die definisieversameling. The domain. X is the element of all real numbers. Nee? Do you guys agree? That graph exists everywhere from left to right. Okay. En wanneer ons kyk na die waardeversameling, dan is dit y groter as 0. Not equal to as well, because it doesn't touch the asymptote. Okay. None of that should be news. Nee? Ons het nou die dag mos hierdie hersien. Now we're going to start working with the inverse function. So now I'm looking for that. So remember, we already have some background knowledge on the inverse function. You know that those 3 points will be on the inverse function, but they would be swapped around. Nee? You know that the domain will be x bigger than 0, and the range will be y is the element of all real numbers. Nee? What we haven't done is we haven't practiced to write the equation of this. So kom ons doen dit. So stem julle saam by die oorspronklike funksie is dit y is gelyk aan 2 tot die mag x. Yes. Okay. What do I do when I want to get the inverse? Swap the x and the y around. Nothing new so far. And now, that skill that we used there, you need to use to get that y out of the exponent. Do you guys see? Because you need the y on its own. So then you write this is y is equal to log 2x. And the more you do this, the less you'll need to do the steps in between. Because this is going to become second nature for you. The number, the actual number goes in the bottom, the x goes next to it. It's always like that. So if my original was y is equal to, let's say, 1/3 to the power of x, it becomes y is equal to log 1/3 x. You get used to it. So you swap them around, and then you write them like that. Maar kom ons, let's walk before we run. Okay, but do you guys see? I'm applying, okay, crawl. Good, let's crawl. Do you guys see I'm applying that rule here? This one I'm doing there. Okay, en dit is hoekom julle dit moes oefen Vrydag. Because now you have the equation of your inverse function. Dit is die vergelijking van jou log functie, jou inverse functie. How do we draw inverse function? If you're able to see the mirroring, you're lucky. I can't see them, I have to study them, but this one looks like this. Onthou julle het julle die 4 vorme laat afteken. Ek dink dit was Vrydag in die eerste periode. Okay. And now, just to complete it, plot those 3 points. So instead of having 0 and 1, you're going to have 1 and 0. Instead of having -1.5, you're going to have it this way around. And this one will be 2 and 1. So gaan plot hulle net vir jou.